Imagine the power you could have as a developer if you could take all of the documentation that you have for the framework or project that you're tooling with and feed it straight into a ChatGPT conversation. That's pretty much what we're going to be looking into in this video by delving into one of the most recent projects put forth by the SuperTokens team. When it comes to these large language models, context is king. You want the right pieces of information pulled in the right place at the right time, whether that be interfaces, classes from any language or framework, or documentation, paragraphs, and pieces of tutorial that you're looking for. We're going to be looking at how we can take actual pieces of documentation or existing code and feed it into a large language model, just like ChatGPT, running on GPT, one of the large language models offered by OpenAI, and get really helpful, relevant information for specific questions that you want to ask about specific items. If you don't already know, SuperTokens is an open source user authentication framework, meaning you can host it yourself if you want to. They have SDKs for React, Vue, Angular, Express, and beyond, so you can have any sort of authentication strategy for any sort of stack you might be running. The team works on more than just auth stuff, though. They have AI development going on, like with a lot of groups, and today we're going to be delving into one of the most recent projects being cooked up by the team, SuperTokens AI. This project, as is the SuperTokens way, is open source, so you can head over to SuperTokens/SuperTokens AI to check it out for yourself, and we're going to be building a chatbot that looks at actual SuperTokens documentation that we have downloaded on our computer that is also accessible and open source, as well as the Discord group for SuperTokens, so it can comb through threads and relevant messages to provide us an interface to have very relevant answers to our very specific questions. In order to accomplish this, we're going to be going over two things in the video, being vector embeddings and the agent model with LLMs. And of course, some demos. We're going to be playing with the CLI and asking some questions. You're going to need Python on your computer if you want to follow along. And you're also going to need the SuperTokens docs, which are open source. Specifically, we're going to be using the version 2 of the docs, which are at GitHub SuperTokens docs. Version 2. To quickly index how these two things will be helping us accomplish the chatbot goal, the vector embeddings will be taking the context, docs, and Discord threads that we want and encoding them into vectors, numbers that we can store either then in a database or in some files on our computer. And the agent model is a way for us to think about how we interact with the large language model. The agents being some mode of thought, being a question-answer prompt, a grader prompt to say, hey, is this relevant or not? And you can have a bunch of these, and we're going to have them interact together in some loop whose behavior can then be changed based on the outputs. We call that loop the executor. The team's hoping by putting out this project, not only can everybody have a personal SuperTokens assistant available to them at all times if they want to integrate with their stack, but also provide a framework from which they can draw parallels for integrating and building their own LLM models within their own products. So we're going to start by cloning the SuperTokens AI repository, making sure we have the SuperTokens docs on our computer. We're then going to go into making sure we have Python set up, making sure we have all of our environment variables correctly set. We're going to build the context for the chatbot by saving into files on our computer, and then we're going to run the chatbot so we can interact with it and ask questions about the SuperTokens product. Now, I already have the repository cloned into my local machine, and I have the SuperTokens docs located a few directories up over at docs/v2. Next thing we want to do is we want to create a virtual environment. So we're going to call the venv module from Python, and then we're going to activate it. And now that it's activated, let's install our requirements from the requirements.txt file. And when those requirements are done installing, you're going to want to copy the env.example file into a .env file so that you can then edit it with your text editor of choice. All right, so your OpenAI key is going to be your OpenAI API key that you can get from your OpenAI account. I usually head into the playgrounds and I can grab it from the UI there. The documentation path is the absolute path on your computer to your documentation. So I have that downloaded in my V2 docs from SuperTokens. Debug, we're going to set that to true because I do want those messages being printed out. For now, we're not going to use GPT-4. We'll only use GPT-3. And in a sec, I'll throw in my OpenAI key here so we can use that. If we head over to the project repo, we can see that we already did step 1, set up an envar. We put in our OpenAI API key, install the requirements. So right here, we can try to ask a question. Let's throw that in there and see what happens. So we're loading a knowledge base, and here we go. We can ask it a question now. Who are you? I'll press Control D. Thinking, I don't know, please reach out to the SuperTokens team on Discord. I mean, that's kind of cool. It already knows that it's doing something related to SuperTokens. And you might be wondering, well, how does it have all this context and all this information you were talking about earlier? Well, it doesn't really yet. And that's what we're going to poke into next. How do we grab information from Discord? How do we grab information from the SuperTokens docs and mix that into our pot of knowledge? Let's dig in. As you know, we can't just take an entire piece of documentation like the SuperTokens docs and feed it straight into a ChatGPT conversation or all the Discord threads from the server. We need some way to index, store, and retrieve the information that is relevant for our task at hand. And that's where vector embeddings come to save the day for us. A vector embedding is just a mathematical model that allows us to take arbitrary pieces of input and map it into a long string of numbers in some multi-dimensional output space. When you open up the project, you'll notice two top-level scripts. There's update.docs.py and update.discord.py. Both of these just reach out to the documentation on your computer locally or the Discord channels up in the Discord servers and generate embeddings to save locally on your computer. So we're going to start by checking out update docs because the two scripts are very similar in the way they handle the information. So we start, of course, with OpenAI because we're going to be using an OpenAI embedding model to actually take our arbitrary inputs and map them to vectors. We're going to be using the regular expression and OS module so that we can read in files from our local computer, tick tokens so that we can serialize and compress our inputs so that they're cheaper for the embedding model to grapple, pandas and some, helper functions so we can read the CSVs of, what we're storing on our file system, and then .m so we can load in the settings that we just sort of set up and configured. Next, you'll notice we're just reading in some files from the file system and filtering if we want some or if we don't want some, and then instantiating the tokenizer so we can start to compress our inputs. Now, the rest of the file is stuff you're probably already familiar with, such as reading a CSV file and making sure that we're adding and subtracting data correctly. But the last thing I want to draw your attention to are these 3 chunk parameters in the chunks array. So 500,024 and 2048. So imagine if we have a document with 1,000 characters and we want to split it into smaller chunks. Do we do it in chunks of 500 or chunks of 2048? That's what we're deciding right here, and we're doing all of them. So we're going to do all 3, and we're going to have 3 different ways that we slice, dice, and store our information locally on our computer for retrieval later in the chat application. And as I mentioned, the update Discord script is mostly the same thing. We're just connecting to a bunch of Discord channels like you can see here, one by one, and grabbing any new threads that might have popped up, slicing and dicing based on the chunk sizes that we predetermined and saving them to disk. So as noted in the project README, once we have all this set up, we can actually run Python update docs and Python update Discord top level just as is, and we can actually have those scripts reach out to the relevant sources and store the info on our computer. I've actually done this a few times, trying different ways to set up the bot, and you can see my usage right here in my OpenAI panel. Every time I train it, I use about 10 or 15 cents, which isn't that bad for calling the embedding models and then actually running chats through it. When the embedding model comes back with your information, the scripts store it in this process directory. So let's actually take a peek in and see what's going on. In one of these CSV files, you can see we have 2 columns, text and embeddings. Surely enough, here's some text, and if we scroll down, here's the bottom of the text, and in the next column, boom, tons of vectors. Specifically, there's 1,536 of them, which is the amount of dimensions that OpenAI uses for their embedding model. 1,536 floating point numbers to describe our input text. Now, I do have to warn you, the first time you do this might take a little bit because it has to go through all the Discord threads and all the docs in your computer and actually run the embedding model for each. Now, I already did it, so we have the most recent and up-to-date Discord threads for our chatbot to look through, which is awesome. So let's boot it up. You can really see how much information is being processed here because it takes a few seconds for the script to load the knowledge base, load the CSVs from our disk. So it's going to load it up into memory, and then we're going to be able to type in a very specific question. Let's see what happens. Okay, the chatbot's loaded up. Let's ask it a specific question. Is there some way for me to save a SuperTokens recipe configuration in a plain text file? It's going to think, and because we have debug on, we're going to see a bunch of output. It's going to run through various Discord threads and pieces of documentation that we might have on our computer, and it's going to ask itself, is this a good answer? Is this a piece of relevant context? Yes, you can create a configuration file for your SuperTokens recipe. The configuration file can be in YAML or JSON format and should be saved in the config folder. So we have something very specific here that's very specific to SuperTokens that actually looked through our context that we have saved on our computer, and it gave us something super useful. So we looked at how we stored the information with vector embeddings, but let's actually poke into the agent model and how we're retrieving and interacting with us as the user on the CLI with that info. As noted in the README, and as you just saw me do, we kick things off with the source main.py script. So we'll hop into there and take a look. We can almost think of this main Python script, this entry point, as our agent executor. It's the main loop that's going to run all of the little agents that we're going to import and do specific things for us. So we're going to start by importing term color. That's how we get the pretty terminal color outputs, and OS so we can interact with the file system and stuff. And we're going to import our agents next. So we have a context agent, which sort of keeps track of the relevant information and that which we are pulling from the file system. Question answer agent, kind of like, just simple QA. A grading agent, which is going to look at what the QA agent gives us and gives us a score. And then we have a human feedback agent for if we want to then give a rebuttal or a follow-up question to any of the other prior agents within this agent executor. Last but not least, we have some utils, some helper functions for getting input from us as the user, and we load our .env, import it, and kind of, set up some debug stuff. We're about to hop into the while loop below so we can take a look at how this agent executor uses the tools it's given to create this beautiful interaction pattern for us. And as we do so, just pay attention to the context agent and how it uses the mode of the plot it's been assigned, as well as the question answer agent, the grading agent, and the human feedback agent, and how they're going to work together to create a dynamic loop that changes based on the inputs and outputs. As we've been saying, an agent is a mode of thought. It's a predetermined way that you can interact with these large language models. So let's actually click into one of the functions on these agents so we can see how simple it really is. You can see from the question answer agent, we import get answer. So this is the function we're going to use to interact with that agent. And it's literally just one function that has a predetermined prompt that it sends over to GPT. It says, you are a friendly developer who's an expert at SuperTokens and authentication. Answer the question based on the context below. And if the question can't be answered with a high degree of certainty based on the context, say, I don't know. Each context starts with the title, new context, and is in a new chat. You can ignore a context if it's not relevant to the question. And if there's no context as relevant, say, I don't know. Do not mention the context directly in your answer. Do not provide code snippets unless it's mentioned in the context already, or if the question specifically asks for code snippets. And that, my friends, is an agent. It's a predetermined way, it's a predetermined mode of thought to interact with a large language model. So the first thing our agent executor does is it clears context for any scene questions. If we click into this, you can see it's really just setting a Python dictionary to be nothing. And it's a global variable, so it's accessible anywhere within our script. Next, we ask the user what they're thinking and get their input with this multi-line input helper function. And then we enter the while loop down here where the agent executor can use the different agents it's been assigned to do the best effort it can at answering our question. And right before we hop into the while loop above, you can see some variables being set, which might help foreshadow some of the dynamic behavior we're going to see down below. Number of bad grade iterations. I mean, we know we're importing a grading agent. This is probably going to be a grade counter. Our previous answer, if we're on the right track or not. Additional context. Maybe this is if we want to give some feedback. So let's go see these in action. Now, since we cleared the context, we got to go get some more relevant pieces of information. That's what this function is going to do right here. Get context. It's from the context agent that you can see imported up above. If we click into this, you can see what we're doing is getting distance from embedded. This function right here is going to read the CSV files from the data we just prepared on your computer, and it's going to look at the 1,536 dimensional vectors and say which one is most relevant to me. And it can use a variety of mathematical operations, vector math, to do this. We're going to be using the cosine distance, which is one of the most common to use. And then just some filter and business logic, such as filtering and sorting and only getting the top percentage that we might want in our context. We're going to take those variables, that data, and store it into our previously cleared context so we can use it to answer new questions. Now, immediately after we get the context, you can see a test being done. If the length of the context, like if the pieces are relevant, documentation or Discord threads that we got back is 0, if there's nothing, well, what do? We're going to say, I don't know, please reach out to the SuperTokens team on Discord. So that's kind of that message that we saw earlier. The other thing that could cause us to say, I don't know, is number of bad iterations. So that's that counter we saw before we hop into the while loop. As our answers get graded, which we'll see in a sec, if those bad grades, those bad iterations pile up, we're going to be kicked out and say, hey, please reach out to SuperTokens. And this is sort of the dynamic behavior that's being put forth by interacting with these agents. So we're getting some context, we're making sure we have enough context, and then we're going to use that get answer from the answer agent. It just sends it over and says, hey, you're a friendly developer at SuperTokens, go help this person. So we're going to get our answer, and then we're going to call this get if answer is on the right track based on grade. And where's that imported from? The grading agent. So as predicted, this is going to say, hey, is this on the right track? Here was the original question, and here's the answer. Does it relate? And if it doesn't, we're going to get dinged for that. So you can see if we're not on the right track, number of bad iterations is going to be incremented by 1. And just to make sure we're on the right track and we're not doing anything crazy, there's another import from that grading agent, is hallucination. And this sort of says, is this just made up? That's a common known problem with large language models. It'll hallucinate and make up information. It'll confidently code something for you even when it's not properly correct. So there's some, back testing we can do against that and say, was this hallucination? And similarly, there's one more call, is hallucination, from the grading agent. So we're going to give it the question, the context, and the answer and say, is this even possible? Like, is this a hallucination? This is a well-known problem with large language models. It'll give you code for something. And it's like, yes, this is the answer. And it's buggy, just like most things that ChatGPT might spit out. So we want to do some filtering, and that's what the is hallucination method from the grading agent allows us to accomplish. If we're not on the right track, bad iterations goes up by 1 so that we have the opportunity to potentially be booted out of the program down the line. Let's try to see this in action by asking, should Tom Cruise use SuperTokens? Now, I have a feeling it's not going to find a lot of super relevant information about Tom Cruise. Surely enough, we can see the grading agent in our output right here giving an answer score of 0. What's really neat is I can see this scanning through the Discord threads and finding, like, should I use? Is this applicable? And it's actually saying, like, it's not relevant to our original answer because none of these are involving SuperTokens. And surely enough, we're getting, I don't know. Please reach out to the SuperTokens team on Discord. So we can see the number of bad iterations probably built up to whatever threshold we have, which I believe is set at 5, and said, sorry, buddy, I don't have an answer for you. And that's great, but I want to draw your attention, guys, to the last bit of the script. You can see enter a new question. So at the end of our agent executor, we can see we print out the answer, we give the answer, and then you reply, enter a new question. And that's where we then do get rephrased question. And this is another important call to an agent. If we scroll up to the top, it's from the human feedback agent. Let's click into this and check it out. So all this is doing is it's saying, rephrase my question above based on the feedback above, so that the next time I ask the question without providing the above question or answer, I get a better answer. Do not miss any code or snippets or any information from the question or feedback. And that's great, guys, but I want to draw your attention to one last piece of this agent executor where it's saying in a new line to ask, well, down here, after we print out the answer, we're going to get a multi-line input and call get rephrased question. And this is another import from the agents up above. from the human feedback agent. So let's click into this and see what's going on. Inside of the human feedback agent, it just takes in the input we have, the question and the answer that it gave, and it says, rephrase my question above based on the feedback so that the next time I ask the question without providing the above question or answer, I get a better answer. Do not miss any of the code snippets or any information from my question or feedback. And it kind of just like spits it out for us. So let's try to invoke this rephrased question mode of thought, this preset way that we can interact with the LLM. Hop back into the terminal and say, Tom Cruise is using Express.js to host his website where he has sensitive pictures of his fighter jet. He would like to authenticate users based on their Google and GitHub logins. Should he use SuperTokens to protect his website's photos of his fighter jet? Now, this, of course, is a really trivial, like useless example, but you can see how the additional building of context is going to go into all the piece of information that we say from Discord and from our docs, and it's probably going to give us a better answer. Oh, look, there it goes. Yes, Tom Cruise can use SuperTokens to authenticate users based on their Google and GitHub logins. However, SuperTokens alone may not be enough to protect his website's photos of his fighter jet. He may need to implement additional security measures such as encryption, access control, and secure storage to ensure his photos are protected. Thank you, bot. Gotta love it. Now, because this project is open source, we definitely invite you guys to comment, and we'd love to hear your suggestions about the prompts that are being given and the ways that we're parsing them. Like, for example, if we get on right track based on grade and we click into this, we can see that we're going to send the question and the answer, and we're going to get some chat completion. And it's going to say, give me a score out of 10, where 10 indicates that the answer is helpful and resolved the question, whereas 0 indicates that the answer is completely wrong, et cetera, et cetera. We're going to get back that output and we're going to parse it into a float. Is 0 to 10 the best way? Should we be using A, B, C, D, E, F? It's really strange the ways that large language models can interact with the ways that we have life modeled in our head. And even further, let's say we do a scale of 0 through 10 on the quality of our answer. We're going to score it and say if it's anything less than a 7, it probably really wasn't good enough. We're not on the right track, so go get more context. Maybe 7 is, maybe we need to be stricter and say you really have to give a value of 9 or 10. Otherwise, the context ain't going to cut it. These are all values for us to play around with and experiment with either in the SuperTokens chatbot, or if you want to adopt and fork this repo to read your own Discord threads and your own files on your own computer. We'd absolutely love to hear from you guys. If you have any suggestions about the way we're tickling the large language models with the prompts within our agents, let us know in the comments below. Or maybe there's a different way we should be grading things. Instead of 0 through 10 on the answer, we should be using A, B, C, D, E, and F. Like teachers use that, so it might flow a little easier. And if your SuperTokens assistant isn't cracking the case for the thing you're trying to figure out, just remember you can always refer back to the SuperTokens docs at supertokens.com/docs. They got incredible guides for every sort of framework, front end or back end, that you might want to integrate with. And it would just be awesome if any of you guys have ideas about some crazy agent executors that we might be able to throw together with this model. Until the next time, we'll see you guys later. Stay secure, my friends.